Okay, I'd start by rewriting this one. Make it h of t equals the tangent, make note of the argument here, 2t minus 1, right? That's the argument on the tangent function. All of this is cubed. So objective here is to take a first and second derivative. Let's work on the first. For the first, we get h prime of t equals, using a chain rule, going to bring the power of 3 down. Right now only working with the power, so the tangent of 2t minus 1 stays as is. Adjust for the new power, subtract 1 away from 3, get 2 back. Okay, now we focus our attention on this inside part. We notice we got a trig function we're dealing with. So, derivative with respect to tangent, what is it? Secant squared. So we're focusing on the trig part right now. Derivative of tangent, secant squared. Argument of 2t minus 1 is going to be the argument on this derivative. Okay, that's kind of my inside piece with respect to the trig stuff. But now it's time to take the derivative of that inside piece. So derivative of 2t minus 1, well, it's just going to be 2, so I tack that on to the end. There's the first derivative. Now, to simplify that a little bit, since I have to take a second derivative, not a whole lot I can do, but maybe at least take the 3, take the 2, multiply it together. Get h prime of t equals be 6. Don't really mind the fact that I've got this tangent of 2t minus 1 raised to the second power, because I know I'm going to have to take a derivative off of that. It just helps to keep it in that form. Also for the secant squared, might help to rewrite that as the secant of 2t minus 1, all that squared. Taking the second derivative now. What kind of rule am I going to have to use here? A whole lot of stuff multiplied, right? It's a product rule. So, as far as this 6 is concerned, the 6 can just tag along with one of these pieces. So I'm going to let the 6 tag along to the first quantity squared here. So you've got this piece times this piece to form my product rule. So taking the derivative of the first piece, got to start with the chain rule idea, right? Take this 2, bring it down. Since there's a 6 in front, we'll multiply, make that 12. Right now, only working with the power. So the tangent of 2t minus 1 stays as is. Adjust for the new power. New power would just be a 1. Now taking the derivative of the inside, well, this is where we start to see some overlap with what we did on the first derivative, right? If we take the derivative of the inside here, we just did that up here. So it's going to be secant squared of 2t minus 1 again, all that times 2. So this is the derivative for the first part. Continuing with the product rule now, we tack on the second part. So we can say secant squared of 2t minus 1, or secant of 2t minus 1, all that squared. Add on first part, unchanged, so 6 times the quantity, tangent of 2t minus 1, all of that squared, or tangent squared of 2t minus 1. And now it's time to take the derivative of this second part. So using the chain rule, bring down the 2. Inside stays the same, because right now we're only working with the power piece. Adjust for the new power. New power is going to be 1. Now it's the inside's turn, right? Take the derivative with respect to secant. With respect to secant, we got that secant-tangent combination, right? So it's secant of the argument, tangent of the argument. So I multiply on secant of this argument, 2t minus 1, times tangent of that argument, 2t minus 1. This takes care of the derivative for secant. Only thing left that we have not taken the derivative of is the 2t minus 1, so I tack on the derivative there, which would be 2. And it's as easy as that.